On the 14th of July, 2015, a spacecraft the size of a grand piano traveling at 58,000 kilometers per hour crossed within 12,500 kilometers of Pluto's surface and kept going. It did not slow down. It could not slow down. It had been falling through space for 9.5 years, and the physics of the journey meant it would pass through the Pluto system in approximately 30 minutes, collect everything it could, and continue out into the dark. The entire scientific return of the mission, every image, every atmospheric measurement, every magnetic field reading, was gathered in half an hour. Then, New Horizons was gone, and Pluto was alone again. What it left behind changed the field entirely. But that story begins decades earlier, and it begins with a decision not to go. Alan Stern is a planetary scientist at the Southwest Research Institute in San Antonio who spent 26 years trying to get a spacecraft to Pluto. He first proposed the mission in 1989. NASA declined. He proposed it again in 1991. Declined again. Through the 1990s, a series of competing concepts, Pluto Fast Flyby, Pluto Express, were proposed, studied, and canceled on grounds of cost or technical risk. The reasons were always reasonable. They were also, Stern argued throughout, wrong. What was being declined was the last first look at a completely unexplored class of planetary body in the solar system. Every other category of planet had been visited. The ice dwarf worlds of the outer solar system had not. He was finally given the mission in 2001. The road to that launch ran through a decision made 3 decades earlier that nearly ended Pluto's chances permanently. In 1964, Gary Flandreau, an engineer at NASA's Jet Propulsion Laboratory, realized that between 1976 and 1977, the outer planets would align in a configuration that occurs only once every 176 years. A spacecraft launched at the right moment could use each planet's gravity in sequence, a gravity assist, in which a planet's orbital energy is transferred to the spacecraft, to tour the entire outer solar system in a single mission. NASA called the concept the Grand Tour and canceled it in 1972 on cost grounds. In its place came the Voyager program. Voyager 1, after its encounter with Saturn, was in a position where a trajectory to Pluto was geometrically possible. NASA chose instead to redirect it toward Titan, Saturn's largest moon, a scientifically justified decision that left Pluto unvisited for another 4 decades. For most of the 20th century, Pluto occupied an awkward position in the solar system's catalog. Clyde Tombaugh discovered it in February of 1930 at the Lowell Observatory in Arizona, and it was promptly designated the 9th planet, a classification it held for 76 years despite accumulating evidence that it was physically unlike the other 8 in every meaningful sense. Its diameter of 2,377 kilometers is smaller than Earth's moon. Its orbit is so elliptical, it periodically crosses inside Neptune's. Its orbital plane is inclined 17 degrees to the rest of the solar system. The reclassification came in 2006, the same year New Horizons launched. When Mike Brown's team at the California Institute of Technology announced the discovery of Eris, a Kuiper Belt object rivaling Pluto in size, the International Astronomical Union was forced to define what a planet actually was. Their definition required a body to have cleared the neighborhood around its orbit. Pluto had not. It was reclassified as a dwarf planet, the largest known member of the Kuiper Belt. The disk of icy debris extending from Neptune's orbit to roughly 50 astronomical units from the Sun. The reclassification changed Pluto's status. It had no effect on New Horizons. The spacecraft launched on the 19th of January 2006 aboard an Atlas V rocket and immediately became the fastest human-made object ever launched from Earth, leaving at approximately 58,000 kilometers per hour. It crossed the orbit of the Moon in 9 hours, a journey the Apollo missions took 3 days to complete. It reached Jupiter 13 months later, where a gravity assist from the giant planet added 14,500 kilometers per hour and bent its trajectory precisely toward Pluto. After Jupiter, New Horizons crossed the outer solar system in effective hibernation, powered by a radioisotope thermoelectric generator using the heat of decaying plutonium. Solar panels are useless at Pluto's distance. The sunlight reaching it, is approximately 1,000 times weaker than at Earth. The flyby occurred on the 14th of July, 2015. New Horizons passed 12,500 kilometers above Pluto's surface at 14 kilometers per second. The signal delay at that distance was 4 hours and 25 minutes each way. The entire flyby sequence was pre-programmed months in advance. No real-time correction was possible. When the team on Earth received confirmation that the spacecraft had survived the encounter, that signal had already been traveling for 4.5 hours. What they were celebrating had already happened before they knew it had happened. The total data collected amounted to approximately 6.5 gigabytes. Transmitting it back to Earth took 16 months. What that data revealed confounded almost every prior expectation. Sputnik Planitia, the left lobe of Pluto's heart-shaped formation, formerly Tombaugh Regio, is a basin approximately 1,000 kilometers across, filled with nitrogen ice circulating in convection cells driven by internal heat. Its surface is geologically young, essentially no impact craters, meaning the ice has been turning over within the last 100,000 years or fewer. Something is generating heat inside Pluto, almost certainly radioactive decay in its rocky core, driving an active geological process at minus 230 degrees Celsius, nearly 5 billion kilometers from the Sun. Nothing was supposed to be happening out there. Something was. The mountains surrounding Sputnik Planitia reach 3,500 meters, comparable to the Alps, and are composed of water ice so cold it functions with the structural rigidity of granite. The reddish surface coating is tholins, complex organic compounds formed when ultraviolet radiation acts on atmospheric nitrogen and methane, which settle onto the surface and give Pluto its color. The atmosphere itself, nitrogen-dominated, with traces of methane and carbon monoxide, produces a blue haze layer visible in backlit images and is escaping into space at several hundred tons of nitrogen per hour. Charon, Pluto's largest moon and half its diameter, is large enough that the two bodies orbit their common center of mass from opposite sides, a true binary system. Its dark polar cap, Mordor Macula, is composed of tholins carried across from Pluto's escaping atmosphere and deposited on Charon's cold pole. The reason no spacecraft is returning to orbit Pluto comes down to one equation. To arrive in a human timescale, a spacecraft must travel fast. To enter orbit, it must slow almost entirely to a stop. Decelerating from 50,000 kilometers per hour at 5 billion kilometers from Earth requires a quantity of fuel that cannot be practically launched. The rocket equation makes this compounding brutally clear. Every kilogram of deceleration fuel must itself be accelerated to interplanetary velocity at launch, which requires more fuel, which requires more still. Nuclear electric propulsion, using a fission reactor to drive ion thrusters, could reduce the fuel penalty significantly and has been studied seriously for this purpose. Aero capture through Pluto's thin atmosphere, using the air itself as a brake, has also been modeled. The atmosphere is tenuous, roughly 100,000 times less dense than Earth's at the surface, but at the right entry angle a spacecraft could shed enough velocity for capture. Both approaches are technically feasible in principle. Neither is funded. The most recent Planetary Science Decadal Survey prioritized a Uranus orbiter over a Pluto mission. No return mission has been approved. The scientists who built New Horizons are in their 50s and 60s. Many will not live to see a Pluto orbiter's data if one launches on any current conceptual schedule. That is not despair. It is the honest geometry of the problem. New Horizons continued past Pluto into the Kuiper Belt. On the 1st of January 2019, it flew past Arrokoth, a contact binary object 6.6 billion kilometers from the Sun. Two gently fused lobes of primitive reddish material assembled in the solar system's first millions of years and preserved undisturbed at minus 200 degrees Celsius ever since. Its shape, two rounded lobes joined at a narrow neck, suggests formation by the slow gravitational collapse of a rotating cloud of pebbles, the two lobes drawing together over millions of years in a collision gentle enough to leave neither damaged. It is among the most pristine objects ever closely observed, material from the solar system's formation, essentially untouched by the violence that reshaped everything closer to the Sun. New Horizons passed it at 3,500 kilometers. As of early 2026, the spacecraft is approximately 8 billion kilometers from Earth, still transmitting data at a rate slower than a dial-up internet connection. Its power source will be exhausted by the early 2030s. After that, it will travel in silence, outward at 50,000 kilometers per hour, into a region no instrument has ever observed from the inside. The 30 minutes of closest approach in July of 2015 have not yet been fully understood, more than a decade later. Papers are still being published. Models are still being refined. One flyby, at 14 kilometers per second, through a system no one had ever seen clearly. And it is still giving back new science every year. The edge of the solar system is not empty, and it is not dead. It is full of objects formed at the dawn of the solar system, preserved in the cold for 4.5 billion years, waiting for instruments precise enough to read them. New Horizons was the first instrument precise enough to read one of them. What it read was more than anyone expected. The rest of the story is still out there, in the dark, exactly where it has always been.